Hello guys, good morning. Welcome to the session today. Hope you all are doing good. So let us start the session. So if you remember, yesterday we had seen what is Google BigQuery, right? Let me go to the BigQuery. So we had seen what is BigQuery. So we know that here we have a project ID dataset. Under the dataset, we will be having tables. And we have created a table, one table that we have created. One table that we have created from editor, BigQuery editor. One table we have created from console, and the one table. Let us try to create a one more table from the shell, and let us also try to create a table from the SDK, from the local. Okay, so let us try to do these things as well. Okay, so for this one, these two things that we have seen yesterday, I'm gonna tell you how we can able to load the data. Okay, for example, if I have some table, or if I have um, a CSV file, if I wanted to create a table by loading the data, so I'm going to use the shell command or SDK command. I will tell you how we can able to do that. Okay, so this is something that let us see. Okay, so let me activate the Cloud Shell. So we're going to be using the BQ load command, guys. BQ load command. You can also check it, BQ load command. So using the BQ command line tool. So how to use it, you can able to see it here. Not running query. I wanted to load the data. Okay. Yeah, here it is. You can see here. See, if you wanted to create a table, create a data set, BQ is the command, make baby names is a data set. Okay. So if you wanted to create, you can able to create a data set like this. And if you wanted to create a table also, you can able to create a table. Okay. So I'm going to create a table by loading the data. Okay. I have it here. So I'm going to do one thing. So first thing what I will do is that I'm going to go to the Cloud Shell. You see here, I'm going to open this Cloud Shell in the one more page. Okay, you need not to remember anything. All the documentation is all there, already there. You can see here. I'm going to copy this command and I'll try to explain you how this command works. Okay, you can see here. So BQ load the table dataset name dot table name and the file name and the schema. Okay, and where the file is. If the file is already available in this location, you have to mention that location. Okay, so this is how. Similarly, I wanted to, let me go to the Cloud Shell. Let me check if I have any file here. Repo thermal. I did not have any file, it seems. Let me upload one of the file. Okay, upload any CSV file or any file. Let me try to upload any file. Okay, so I have some customer CSV. Yeah, or product sales. It's no products. Yeah. So I have here product CSV. I wanted to upload this thing. Okay, I wanted to upload this thing. First, I will try to upload it here. Okay, first I will try to upload it here. Products. So from where I'm uploading, you can click on these three dots. You have an upload option here, download option here. You can click on upload, automatically it will be uploaded to your cloud shell. When you click on ls, you will be able to see products.csv. Okay, now for this particular thing, I wanted to write a frame a query. Okay, I wanted to frame a query. So the same query I'm going to frame it. BQ load data set name where we wanted to create this table. So I wanted to create this table under this landing data set. Okay, so I will go to landing dot the table name I wanted to give as products table. Okay, the table name I have given as products table, and the file name is you already know. The file name is this one, products.csv, right? And now we have to mention the schema properly. Okay, we have to mention the schema properly. The file is this one. Okay, the file is this one. I'm going to copy this entire thing, column names. I'm going to paste it here. Product ID. I would just say product ID is a string or integer. Okay, integer, int, integer. Name is a string. Category is a string. And price is a float. Okay, so this is how I'm doing it. And I'm going to copy this thing. Okay, I'm going to copy this thing and paste it here. Okay, I'm going to click on enter. Authorize the cloud shell. Okay, bq load command I'm using, sir. bq load command I'm using. Okay, we have to specify. It is saying that you have to specify current status is done. Okay, but it is saying some error while reading the data couldn't parse product ID as int 6. Okay. So because I do not know how it has how they have mentioned it here. Usually whenever we maintain integer, it is a int 64. Okay, see here. But I don't know why it is current status is done. Let me check it here if it has done or not. Okay, it is not completed here. So I don't know why it has completed here. Okay, if I wanted to, I see a error here, guys. You are loading the data without specifying the source format. So for that one, what I will do, I will come here and I will try to mention the source format as well. Okay, it is asking that bq load is fine. Somewhere I will mention source format. Okay. Okay, one thing I will do, sir. I will make it, I will break down this code. Okay, I will break down this code. I will just say, this is fine. Landing dataset is fine. Slash products. This one, products.csv is also fine because this is a location where I have it. And that's also fine. And slash, this is schema, I will say. This is schema. I will say schema, I will be mentioning the code. And it is not integer, I will just say int 64. And here also float 64, I will just say. And for the string, it is fine. Okay, I will just say string. Okay, this is fine for me. Schema is properly defined. And slash. And source format also it is asking. I will just say hyphen. What is the command here? It is source format, right? So source format I will copy. And I'll come here. I will mention source format is equal to CSV. It's CSV file, right? You see here, it is CSV file. I mentioned it is CSV. Let me try to run this code now. Okay, if any errors comes up, we will see. Let me clear the screen. Let me clear this. Hope you are all able to hear me, sir. Hope you are all able to hear me. Please confirm once. Here, great. So something wrong again. Flag schema appears after final command line argument. So please reposition the flag and BQ help. Okay, what it is saying that the schema flag appears after the final line argument. So it should not be at the final line argument. So let me reposition it. Okay. So what he is saying is that let me copy this schema field. Control X. I don't know why they have why it worked for them, but how it is worked for them, I will try to mention it like this. And the source format also I will try to mention it after here. Okay, and table name. Yeah, I think this should work now. I have repositioned it. This should work now. Enough position argument. Still looking for destination table.
Backslash is missing in the second line.
Oh, it's okay. Control that. Sometimes this is a problem. Okay, backslash is missing, and here it is not required. Perfect. We come here, paste it. Upload complete, and okay. I got it, guys. Okay. Can anyone tell me what is the problem? Can you guys tell me? No. Data set name we have given properly. See, it is a data land. Look at the data and tell me what is the problem. See, error message reading the data. Error message CSV processing encountered too many errors. Giving up rows is equal to 1, errors is equal to 1, maximum bad equal 0, errors are 0. So what it is saying is that, see, you have mentioned the schema. The product ID is you have mentioned as integer, but it is considering this entire data as a products data, and it went to the first row, and this is not an integer. Product ID is not an integer. Okay, what it is saying is that product ID is not an integer. You can see here, error while reading the data error could not parse the product ID as an integer. That means it is considering everything as a data. We should mention that there is a header row, right? We should mention that there is a header row. So we should mention skip header row is equals to 1 somewhere. Skip header, skip leading rows or something somewhere. We have to mention that line. I'm not sure where how that works. Skip leading rows is equal to 1. I'm not sure this thing. I just wanted to know, because I mean, skip leading rows is fine, the concept is fine, but the command, is it the skipping header rows is equal to 1 or leading rows is equal to 1? I'm not sure. Let us try to check it. Current status running. Yes, perfect. Skipping leading rows is equal to 1 is the correct line. So I thought of like skip header rows is equal to 1. Okay, so that's fine. So now if I go to my landing data set and if I refresh it here, I have a products table. You see here, just now it is created, and preview. Okay, so BQ load command is very famous, guys. Don't think that's why we are using this BQ load command. BQ load command is one of the very famous commands, so everyone must know. Okay, everyone must know. I'm going to copy this BQ load command in our in our these things also, cloud shell. Okay, paste it here. I have pasted it in the big here also, guys. Okay, so you can also later look at it. And likewise, sir, it is big load command is fine because I have the file inside my cloud shell, so that's the reason you have uploaded it. That's perfectly fine. But what if I have the file is not there in the cloud shell, but it is in my local machine? How do I do that, guys? Guys, the question is, if I have my file inside the cloud shell, I have done it. Cloud shell machine, I have done it. Okay, what if I have my file? Let's just say, let us take one of the table. Let me keep one of the table here, one of the CSV file here. Give me 1 minute. Somewhere it will be. Data sets, I'm not getting the data sets. Yeah. So assume that I have a file here. Okay, assume that I have a file here. Let me open this file also. See here. Sir, I have a file. This is in my local machine. This is on my desktop, local machine desktop. Earlier, the products table also was in the local machine, but first I loaded it to the cloud shell and then in. But I don't want it to load it to the cloud shell because I assume that this could be a very heavy file or a lengthy file. I wanted to load this to the BigQuery table from the local machine directly. From the local machine directly. So for that one, what I'm going to do is that you already know how to use SDK. I told you, okay, how to use SDK. So try to install the SDK. Once you install the SDK, this is how the home first page looks like. So once you have entered into the SDK, you can gcloud auth login, authentication login. So whenever you do this thing, it will be going to the login page. It will be not here, not here. It shouldn't go to this one. It should come to here. Okay, gcloud. No. Let me close this thing. SDK. gcloud auth login. Okay. No. This is again opening in this thing. It shouldn't open because it should open it here. Otherwise, if it is not opening here, it will be a problem for me. I can do that. I can do that. But if it's directly opening it here, gcloud login. Yes. Okay. Login. I can do that. Now I'm going to select this account. I'm going to allow it. So it is allowed. So that means we have logged in and we set the project. What is our project, sir? Go and look at my project ID. My project ID is GCP morning batch. My project ID is GCP morning batch. Okay, I have to set my project properly. So what I will do, gcloud. You can see here, you already have the command here, gcloud. Correct. And we mention the project ID and we will be changing the project ID. So updated the property. Perfect, right? So now I wanted to, you see here, where are you now? You see here users the data local, you are in some location. So now assume that, okay, I'm gonna get this path of this particular file. You can click on this thing and show more options and click on the properties. When you click on the properties of this particular file, you can click on this location. You see here, the location is this one. The file location is this one. I'm going to copy this file location. First, I will go to my same command. I'm going to paste here the file, and the file name is em- employee.txt. Okay, employee.txt. This is my file name. Okay, so this is the location of the file. Same thing, I'm going to copy this entire thing. I'm going to paste it here. The location of the file is Control X, and it was asking the file location. Yeah, here it is. I'm going to mention this thing. Okay, so what I have done, sir, I didn't do anything. I'm just changing the path. Okay, I just only changed the path so far. But is it enough? We have to change the schema also, right? So the schema is not, this is not the schema properly. Okay, for the schema, I will open my file, get this column names, Control C. I'm gonna paste it here first. Okay, first employee ID, Control X, project ID, first name, last name, department, and we have a one more also, salary. Okay, I'm framing the query properly. Okay, let me try to, what I will do, let me try to, employee ID is string, right? First name, last name, sorry, employee ID integer, first name, last name string, department is integer string, sorry, HR department, something like that, right? So let me cancel this thing, and the salary is okay, integer into 64. Okay, and close this. So schema properly defined. Look at the schema, sir. Any issues with the schema? Employee ID integer, first name, last name, department, salary, and source format is not CSV, it is text file. Or you can also mention CSV. That's also perfectly fine. Okay, skipping leading rows, you can also check it here what they have mentioned. Source format they did not mention. Okay, that's fine. Skipping leading rows is equal to 1, perfect. And the table name I wanted to mention as, it is not a products table, this is employees table, employee table, and this is the location. Perfect. I'm going to copy this thing. Don't go to the cloud shell, go here. And okay, you can't paste it like this because it will not allow, because the cloud SDK is different, cloud shell is different, so you have to remove these things and copy. And for now, I can, for your understanding, I'm going to copy this thing. Okay, I'm going to paste it somewhere here. What I will do, because these slashes are not able to read by that, so that's the reason. Okay, copy and go to here and paste it. Okay, bq load command, schema properly defined, source format is defined, leading rows defined, data set name and table name defined, location defined. Click on enter. Okay, see, done. Current status is done. Go to your BigQuery and try to refresh this thing. You have employee table also. Click on the employee table and see we have these things employed, all of those things. Details also 5 rows. You can also see the data. Okay, earlier also you can also look at the data. Okay, here also you have the data. Here also you have the data. So this is how you can able to load the data from console, editor, console, shell, and SDK. Okay, so this is how you can able to load the data from all of these things, guys. I'm telling you. Okay, so this is also command that I am pasting here. This command also I will paste it here. Sorry, this command also I will paste it here. So let me remove this command. I don't need this command. Usually for understanding purpose, Okay, so this is also, I will remove it. I will just say we have created from the console, we have created from the editor, we have created from the shell, we have created a table from the SDK. Okay, I'm going to copy this entire thing and upload it in the notes. You will be able to see it in the notes, guys. Okay, later you can see. Okay, yeah. So this is done. Sir, so far, so good. We have created all the tables from everything. That means we will be able to load any file format to from wherever it is, we will be able to load it. The only thing we have to do is that if it is a local machine, we have to install the SDK. If it's a local machine, we have to install the SDK. If it's already available in the shell, you can able to load it. And you wanted to manually create it and insert it, go to the Cloud Shell editor. Or you can, if you want, if you have some file and you wanted to do it via console, you can also do it via console. Okay, so all of those things that we have learned so far, so good. Sir, I'm gonna tell you one more concept today. That is, so if you remember, whenever we are creating a table from the console, whenever we are creating a table from the console, let me take uploading a file, and let me take one of the file. Okay, some employee file only. Let me take this employee text file only, and I will just say CSV it is. And you have a native, and you will mention some employee. I will just say partition. Okay, partition table. Partition table. Okay, I wanted to tell you about the concept of partitions. What is a partition concept is I will try to tell you now. Okay, so we are going to create a partition table. What is the advantage of the partition? Let me try to tell you. Paint. The paint is not working good actually, but yeah, anyway, no problem. See here, guys. See, you have a very large table. Assume that you have a very large table. Okay, the concept of partitions is this one. See, if I have a very large table, whenever I write a query, what it will do, sir? How the query execution plan, can anyone tell me? For example, I am writing a query like select star from this particular table where ID is equal to 106. ID is equal to 106. Can anyone tell me what could happen when I write this query and what will happen in the backend? What will happen in the backend? So usually what happens is that, let me try to tell you, in the BigQuery, the architecture of the BigQuery will be like this. The architecture of the BigQuery will be like this. Okay, so you will be having three main components. One is Colossus distributed file system, and the next component is, the second important component is processing engine. That is Dremel processing engine. Dremel engine. People call it as Dremel engine. Dremel. Okay. And the third one is petabyte network. Jupyter network. Okay. So Colossus distributed file system. Whatever the table that you are creating and loading, right? All the data, all the storage will be done here. This is called as a storage layer. People will be asking, sir, can you tell me about your BigQuery architecture? So this is what it is, the architecture of the BigQuery. It is a storage layer. Whatever the table that you are creating, right? All the tabular data will be, storage will be done here in the CDFS. And CDFS, the concept of CDFS is very simple. Colossus distributed file system. All the data will be distributed to the multiple file systems. Okay, one system cannot be able to store the entire data, so that's where multiple file systems will be sharing the data. So the data will be distributed to the multiple file system. Okay, so that is what is the storage layer. Now, so user will be running some query. Assume that you are a user here. Assume that you are a user here. What you will be doing is that you are running some query. Okay, you are running some query. That query will be submitted to your Dremel engine because Dremel is the processing engine. Dremel is your processing engine. Dremel is your processing engine. What this processing engine will do is that you have mentioned this query. You have mentioned select star from table where id is equal to 6. What it will do, if it needs to process the data, it needs the data. It needs to process the query, it needs the data. Okay, so via Jupyter network, the data table or data will be moved from here to here via Jupyter network. Data will be moving from CDFS to the Dremel engine for the processing purpose. And according to the data, it will be processing. Dremel engine will be processing the data. But what will happen is that Dremel will try to scan this entire table because you have mentioned a select star from table where id is equal to 16, 106. First, it will scan the entire table. Okay, so assume that you have this table is this many columns. Okay, you have an id column here. First, it will scan this entire table. Then it will go to the id column and it will look for 106. Then that data will be printed. That data for that query, that data will be returned. That data will be returned. So that's how it works. So that is how the architecture will be taking care of it. Backend CDFS is actually storing the tabular data, and Jupyter is moving the data from this layer to this layer because it's a petabyte network. It is a very fast network, sir. It is a petabyte network. And Dremel is the processing engine. It will be doing the processing with the help of multiple virtual machines will be connected, sir. Multiple virtual machines will be there to process this data because it's a cluster kind of a tool you can think of. Multiple virtual machines will be there. It will be processing your query based on with the help of these worker nodes. And based on the query, what the Dremel will do is that first it will scan the entire table, then it will go to the ID column and it will get the 106 record and all the records, all the columns related to star means all the columns related to that data will be returned here. Okay, the data will be returned here in the form of a table. So that's how it works. Okay, so that's how the data will be returned. What is the problem here? What is the problem here? This is the problem, sir. This step is problem. See here, what is the correct? So we are scanning the entire table, but I don't want it to scan the entire table. If it is a very huge table, it takes a lot of time. It takes a lot of time if it is a very huge table. So that is where concept of partitions came into the picture. That's one of the storage optimization technique in the BigQuery, where you can able to divide your table into the parts. Okay, where you will be able to divide your table into the parts. What you will be doing here? What you will be doing here is that instead of reading the data from this entire table, what you will do is that while you are creating this particular table will be there at some point of time, this table was also created. While creating this table, you don't create it like this, you actually create it into the partitions based on the partitioning criteria. I will tell you about the partitioning criteria, don't worry about it. Okay, based on the partition criteria, the table will be divided into multiple parts, something like this. This is one part, this is one more part, this is one more part, this is one more part. Assume that I am just mentioning only, assume that only four partitions are there in this table. You can think of like there will be many. For our illustration, I am mentioning 4. Okay, so what is happening, sir? Assume that based on the partitioning criteria can be like this. So you have some 100 records, some 200 records. Okay, you have some 200 records. So from 1 to 50 records are here. Some 51 to 100 records are here. Some 101 to 150 records are here. So 151 to 200 records are here. Okay, so this is how the partitioning criteria based on the integer column. I am based on the integer column, I am partitioning the data. So this is my integer in column. So I am partitioned the data. So the criteria is this one. Every partition will have 50 records. That is my partitioning criteria. Based on the integer column, I am converting dividing the large table into the partitions based on the partitioning criteria. My criteria is this one. The column is partitioning column is integer column, that is ID, and for each column the what I would say the number of records for each partition is 50 records. Okay, if you have 50 more records or 10 more records added, that one more partition will be created. Okay, that means 201 to 250, one more partition will be added. So that's how each partition will be created. Okay, so this is how what happening. So instead of having a large table, we have created a partitioned tables. Okay, this is small partition. Okay, you can think of like based on the partitioning criteria. Now look at the query here. Now look at the query. Select a star from table where ID is equal to 106. Okay, managing the, so this is what it is. So when you are working in a project, you don't complete the entire project in one day. You don't complete the entire project in one day. What you will do, you will be having a sprint based mechanisms, or you will be having a day wise completion task. So you will be having a target of, okay, this day I am completing this amount of task, tomorrow this amount of task. So you will be dividing your task in such a way that you are dividing it into a manageable pieces. Likewise, when I have a very large data, I will be dividing the data into a manageable pieces. So whenever I run the queries, the same query if I run it, the same query if you run it, okay, now tell me, sir, do I have to go to each table or I can look at the partitioning criteria? So if I look at the partitioning criteria, I'll come to know that 106 is where. The 106 can be in this table because by looking at the partitioning criteria, I'll be able to understand it. Okay, this is where 106 couldn't be. In this table, 106 can be in this table. 106 can be in this table because based on the partitioning criteria, I have come the BigQuery come to know, and it will just read. It will just scan only this small amount of table. Only the small table it will scan now. So that scanning will be sure, but now scanning the small table, then ID column is equal to 106. That's where it will be returning the rows. Okay. So what will happen due to this one? Scanning time is very simple. Scanning time is reduced because we are not scanning the large table. If you have some 50 partitions, usually BigQuery supports like 2000 partitions. Maximum number of partitions 4000 or 2000. I usually confuse. Max number of, this is one of the question in the maximum number of partitions in BigQuery did not come in BigQuery. 2000 or 4000. Yeah, 4000 partitions. You can actually go for maximum number of partitions per table is this one, 4000 partitions. You can go. Don't forget this one, guys. People will be asking you. BigQuery supports how many partitions? 4000 partitions. Maximum per one table, you can create more 1000 partitions. Okay. Now, so if you have some 4000 partitions, means small tables are there. Okay, very small. Okay, reading the small tables is very easy, right? Just managing the simple pieces of the data is very easy instead of managing the entire data on the RAM. So that's where, because that's where the scanning time is reduced. The advantage with this concept is that the advantage that you get is that whenever you're scanning, the number of bytes are reduced. Number of bytes are reduced, guys, right? Because you are not scanning the entire table, you are scanning only the small amount of data. So the number of bytes reduced, When the number of bytes reduced means the cost of the query is reduced. The cost of query reduced. That means cost is reduced. And time taken for the query to run is reduced. Time taken is reduced. Okay. So the number of parts, the F, the time taken, the cost of the query, the number of bytes. Perfect. This is what we need. So this is what is the optimization technique in that BigQuery. Okay, this is what we need, sir. Because they wanted to reduce the time taken for the query. They wanted to reduce the cost of the query. They wanted to reduce the number of bytes processed for the query. So all of those things are reduced. Okay, so this is a concept of partitions. Okay, so dividing a large table into a small parts, small manageable parts is nothing but a small chunks also they will call. Dividing a large table into a smaller chunks is nothing but a partitions. Okay, if you wanted to learn more about the partitions, you can go to the partitioning in the BigQuery. Okay, okay, it's not this one. Usually I'll go to the public documentation. Okay, if we have it here, managing resources, managing, let me, okay, not it, it's not here. Okay, BigQuery. If you wanted to learn more about it, okay, BigQuery partitioning. Oh, I did not select partitioning and clustering. Introduction to cluster tables. No, I wanted to go to partitioning first. Okay, introduction to the partitioned tables. The concept is very simple. You see here, a partitioned table is divided into segments called partitions. That takes it easier to manage and query your data. So you are making it easier to manage the data. Okay, you are making it easier to manage the data and query your data. So what you are doing, by dividing a large table into smaller partitions, you can improve the performance and control the cost by reducing the number of bytes processed for reading a query. Okay, your partition table, you partition table by specifying a partitioning column which can be used to segment the column. So partitioning criteria is must. Okay, so this is how it is. Let me go to BigQuery and let us try to see how we can create a partitioned table. Okay, let us try to create how we can create a partitioned table. Okay, you see here, partition table can only be one table, sir. Okay, oh, sorry. In a partition, the column can be only one partitioning column. You cannot have a multiple columns as your partitioning column. Partitioning column is equal to only one. You can only have a one column as your partitioning column. Okay, you cannot have more than one column. This is also one question. Only one partitioning column can be allowed in a table, BigQuery table. And when you have to create this partition, sir, I have my table created. And now earlier when I was using this table, I did not know that. But now the table is becoming very huge. I wanted to convert that into the partitioned table. Is it possible? Is it possible, sir? The question is, can I convert the table into the partitioned table later? Is it possible? No. The answer is no. Some people are saying yes, but the answer is no. You cannot convert a table to a partitioned table later. Okay, if the table is already created. Okay, so that is what it is. You can only create the partitioned table while you are creating the table. Okay, while you create the table only, you have to make it as a partitioned table. You cannot convert it later. Okay, now I will go to here and let us try to see from the console. I am going to create a table, upload employee.txt CSV file. It is employee partition the table. I will just say employee partition table, and the schema I wanted to mention. And let me look at the schema. I forgot, where is our schema, sir? Where is our data? Somewhere we have employee date table, right? So this one. Okay, so let me come here. Let me open it here. Okay, so you can just copy this thing. For me, what I'll do is that I'll just copy this thing, and I will go here, and I will also tell you one more step. That's the reason I'm trying to create a table. Okay, I wanted to mention date also, sir. Okay, so date of birth I wanted to mention. For this only, date of birth I wanted to mention. Or yesterday, did we create any table? Have we created any table? 1 minute. Yesterday, I think we have created one table. Give me 1 minute. Okay, 1 minute. Let me look at the yesterday's data. With the column first name, last name, department. Yeah. Okay, so I have it here. So that is employee ID, first name, last name, age. First, let me tell you the column names. This is my column names. I'm going to create a one more employee table. Let me try to update it here. This is my column names. Okay, employee ID, first name, last name, age, department, salary, hire date. Because I wanted to have a date column also. So that's the reason I have mentioned the date column. I wanted a float values. I wanted a string. I want integer. I want integer. That's fine. Okay. So you can also mention these things. Okay, control S. What I wanted to do, copy this thing. Okay, copy this thing. And I'm going to paste it here. Okay, I'm going to unselect it, and you have employee ID. I want it to be an integer, full name string, last name string, age integer, department fine, salary I wanted it to be a float, hire date I wanted it to be a date. Okay, perfecto. And this thing, let us try to reload it because we just updated something, right? Where is that? Employees. Perfect. Okay, so we have mentioned all of these things. Now there is a one more concept also, that is the what we call it as you can see here, the partition and clustering is a topic, and in this one by default the partitioning is no partitioning will be there. If you wanted to enable the partitioning, you can see here, you can always go the partitioning with the ingestion time. You can always create a table by default. If you wanted to create a table with the ingestion time, you can always go with the partitioning based on the ingestion time. What is mean by ingestion time, sir? Whenever the table data is inserted, assume like this, assume like this is very small table. This is not increasing at all. No, it is not increasing at all. Okay, now see here. See, now assume that you have a table, and the table data, one record is added today, next record added tomorrow, The date record added one more day. Okay, so based on the time, so based on the ingestion time, you can see here this is these records are one record, second record, third record, fourth record, fifth records are there, right? So each record will be added at some point of time. Based on the ingestion time, you can create a partition. That is nothing but in this entire month, in 1 month, whatever the data is inserted, right? Whatever the data is inserted, that is one partition. So based on month-wise partition, nothing but each data, whenever the in particular month, whatever the data is inserted, right? That is one partition. Month-wise partition. You can also day-wise partition. In the day, whatever the data is inserted, right? Day-wise partitions also you can go. Whatever the data is inserted into that particular day, that is called as a day-wise partition, because each record, whatever you add, it will be having its own timestamp. So whenever you are adding this particular record, with this data, you will be having also the ingestion time attached to it. So ingestion time. So if this ingestion time, based on this ingestion time, if you wanted to create a partition, you can do that. Okay, you can create a partitioning based on this ingestion time. No, sir, I don't want it to go with the ingestion time. And you can see here employee ID, age, and hire date. Can you guys tell me why we are seeing these things? Why we are seeing these things? Because these are the qualified columns for the partition. These are the qualified. Why we are not seeing all the columns? Why we are not seeing all the columns? Because string columns are we cannot do the partitioning column as a string column. We cannot go for a partitioning column as a string column. We cannot go for a float columns as the string columns. So that's the reason you will not be able to see first name, last name, salary. First name, last name, department, and salary. You don't see it here. I have like 7 columns, but I only see 3 columns here, because first name, last name, department, salary are the string and float columns. You don't see here. So the only allowed columns for the partitioning will be integer columns, date columns. Date means date time. You can also mention date time. You can also mention timestamp. Okay. Date columns are like, you can also mention date, time, timestamp, time column. So all of those things you can mention. Okay. So there are only 2 categories of columns that the partitioning can be done. Only 2 qualified columns can be partitioning, that is integer or date columns. Integer columns or date columns. Okay. Now see the magic. If I select the integer, what I have to do? So I mean, if you don't want it to go these things, you can actually go for the ingestion time. So the third category of partitioning column can be ingestion time. Okay, so 3 columns we can go for partitioning. Total 3 columns we can go for partitioning, sir. One is integer columns, one more is date time columns, the third one is ingestion time columns. Okay, these are the 3 qualified columns. Okay, now, sir, so far this is the columns, but what is the criteria where I have to mention the partitioning criteria? You told like, sir, I have told like 1 to 50, 51 to, sir, where is that criteria? How I have to mention? That's where now, sir, I wanted to select the integer column, that is employee ID. Now you see here, it is asking for the criteria. You have to mention the criteria properly. So this is where, sir, starting records are. So you can see here starting records are starting value. For example, for this table, I have like 4 records. Okay, starting and ending is 4. Most of the times we do not know ending. We will be mentioning something, but now I'm mentioning. I know that ending I mentioned. Each interval is 1, and later we will worry about the cluster. Okay, so partitioning column is partitioning column employee ID, that is integer column I have selected. A start value, end value, interval. This is what I was talking about. Interval means every 50 records that I was telling you right here. Every 50 records is one partition. Now every 1 record is one partition, because I have only 4 records, so that's the reason I have selected. Usually if it is having some 100 records, right? So that's where we will be selecting more number of interval. Usually they don't actually go for the integer. Okay. If I have to say, they don't go for the integer, but you have to understand the integer concept as well. Okay. Now you selected integer, and now you can create a table. And meanwhile, let us try to understand the clustering also. Okay. So partitioning based on the integer column, that we have done. That this is how the criteria we have to mention. For the clustering also very simple. What the people say is that, this is what the people say. Sir, I have a table and I have a ID column. The ID numbers are like this: 2, 5, 7, 1, 3, 4. Okay. Okay, so this is what, where the ID columns are not properly sorted. ID columns are not properly sorted. It is in a random order: 2, 5, 7, 1, 3, 4, and this is 1. And now I have a same table which is sorted: ID 1, 2, 3, 4, 5, 6, 7. Now tell me, out of these two, if I run a query on this thing, if I run a query on this thing, which is faster? Can you guys, anyone tell me? And why? Second one. For those people who couldn't able to say the answer, they can think like this. If you have some 100 persons in the one room and you need only one person, but you did not meet him so far, but you know his ID number only. ID is equal to some 51, 52. And how do you do that? You cannot go to a random person and ask him like your ID number is 51 or not, right? If they are in a line, you will be able to easily get the 51. Okay, so that means if they are in a random, you do not know how to ask them. If you are lucky, you will directly go and ask the direct 51 person. But if you are not lucky, you will not know how to get him. So what you have to do, if they are in a line, right? Okay, you will keep on counting the numbers. So that's all. So whenever you are writing a query on a random sorted data, then the query actually takes some time. But when it is sorted properly, the query time will be lesser comparatively. The query time will be lesser here. So that's the reason. So we always try to sort the data. Okay, we always try to sort the data based on some column order. If the integer, if it is an integer column, we will be trying to sort the column based on the numerical order. If it is a string column, we will be sorting the based on the alphabetical order. If it is a date time, it will be based on the date. If it is some, I think that's it, right? Yeah. So this is how, if you try to sort the data, the table query performance will be improved. If you sort the data, the query performance will be improved. Now that's where the clustering is. Clustering is nothing but a, if you say clustering, this is what is clustering only. Okay. This is what clustering only. Clustering is nothing but a sorting the table based on column order, based on one column order. One or maximum 4 columns we can go based on column order. Column, okay? Column data type, whatever it is, okay? So you are going to sort the table based on the one column. Okay, so that is what is nothing but a clustering. So you can go maximum up to 4 columns. Maximum up to 4 columns you can go. And for the partitioning, how many columns, sir? Maximum columns for the partitioning. No, I mean to say the column, the partitioning column. Only one, sir. Don't confuse. Okay, the only column, partitioning column can be only one. Did I say that? No, right? The maximum only column is one. I told you. I think somewhere I told. Yeah, here it is. Partitioning column can only be one. But the number of partitions per one table. That means these chunks. This is one, this is two, this is three, four, five, until 4,000 we can have. But the column can be only one. Okay. But here the column can be 4 columns. Okay. Maximum 4 columns we can able to do it. Okay. So this is how we can go to clustered concept as well. Now, sir, here what they are asking, cluster order determines the sorting of the data. The same thing that just now we have seen. Cluster order determines the sort order of the data. One more thing I am telling you guys. Clustering can be done on both partitioned table, non-partitioned table. This was one of the question in the AS exam, Associate Cloud Engineer exam. They asked this one, can I apply the clustering on a non-partitioned tables? Can we apply clustering on non-partitioned tables? Guys, can we apply clustering on non-partitioned tables? Yes. From this statement, we can say that clustering does not have a dependency on the partitioning. We can create a clustering on partitioned table and non-partitioned table also. Okay, so clustering is nothing but a sorting the sort order of the data. Okay, so I'm going to select. Now I wanted to sort it based on the employee ID. Okay, I'm going to select 4 columns. I will select. Okay, if I try to select all the columns, you see here what is the problem. Oh, why it did not throw an error? Did they try to increase or something? Let me try to create a table. Okay, no worries. And we will see if it is throwing an error. So you come here, write if empty, this thing, comma, separated, double quote, header rows to skip is 1. Okay, all the things are done. I'm going to click on create table. Click on create table. Number of columns, clustering. I'm going to go for the clustering in BigQuery. Okay, introduction to the cluster tables. Clustering in BigQuery R have a user defined column sorted based on the clustered columns. You can see here. You can just look at here. When to use clustering if you wanted to. You can allowed columns. So earlier I was telling, this is also one more thing I forgot to tell you guys. Allowed columns, right? So the allowed columns for the partitioning is integer, date, time columns. Okay, but here for the cluster, you can also apply clustering on string also. Okay, but float no. But you can apply on string columns also. Okay, only one thing that you have to understand. Yeah, you can see the examples. And what was I was talking, the number of columns, right? So okay, let me see, look at here. It is created. It is still creating. I don't know why it is still creating. So the number of columns I'm looking at, maximum number of columns. Yes, yes. Ah, yeah, that is fine. But it's supposed to throw me an error saying that because I have mentioned more than 4 columns, right? So I was expecting that. Okay, let me cancel it because we have waited a lot of time here. So that's the reason it was not creating any. So let me create one more time and click on upload employee and copy the schema and table name is employee partition. Ah, yes, file format is CSV and edit as schema and edit it. It is integer. Oh, it is department, sorry, age and salary. Add date, clustering by employee ID 1, 4, 1. Clustering can be, it should throw an error. I don't know why it is not throwing, but let's see. Click on create table. Field salary is a type float which is not supported in the clustering. That's perfect. Okay, so float is not supported, so I'm gonna remove it, and it's gonna throwing an error. You see, and maximum number of 6 cluster fields specified exceeding the limit of 4. So clustering can only be done on 4 columns. Okay, for now I'll just will be done on 3 columns or 2 columns only. I'll be doing it, and click on create table. Okay, the table is created. So you have employee normal table, you have an employee partition table. You can see here. Whenever you open this table, you will be able to see it. This is a partition table. If you wanted to open this employee table also, you can able to see. Click on this tick, right click on it. So you have a employee partition table, employee normal table. So you can able to buy whenever you open the table, it will say it's a partition table. Now this is right side one is not partition table. And details, if you go, table type is a partition, and partitioning start for this one interval and cluster by this column. But if you go to the details, you don't see those details because it's not a partition table. The number of records are 4, the number of records are 5. Okay, earlier we have changed the data actually, so we changed the data. This one we have actually 7 columns here, we have only 4 columns here, 5 columns here. Okay, so that's how the partitioning table and non-partitioning table looks like, and the performance will be achieved when you actually have a large amount of the data. If you have some 100 records of the data, if you try to check the performance, you don't get it. You don't get that much performance because you don't see that. It will be always, it will be in milliseconds only, right? So you don't see. But when you have a large amount of the data, you'll be able to see it easily. Okay, so this is the concept of partition table and non-partition table, and we will see a few more examples tomorrow. Okay, this is how we can able to create a partition table from the console, and we will see tomorrow with a few more examples. Okay, go to your documentation, read it out at least 2 or 3 sentences. You will be able to get a very good knowledge. Always do that. Make your public documentation as your resource file. Okay, and always I have my file ready, and which gives you some idea. Okay, you can go to the partitioning, and you can see here native table, external table, partitioning, storage optimization techniques, partitioning and clustering. What is a partitioning, sir? Okay, you can see here dividing a large table. You can see here dividing a large table into smaller chunks. Everything is here. Benefits, limitations. Clustering also same. Everything is mentioned here properly. You can also go to here, or you can also click on this link and go to the partitioning tables to create a table and all of those things. Okay, yeah. Okay, guys, this is it for today. Any questions?
Sir, can you share these notes to me, please?
Range interval. Yes, range is nothing but how many number of records you wanted it to keep. Okay, so that's all. Into one specific partition, yes. Interval means this in that particular table, in that particular partition, I'll be having this many records. Usually we don't actually go for integer. It's for you to teach you, but no one prefer the integer as a partitioning column because you do not know the end value. Okay, so that's the reason no one will be going to that. Yeah, but mostly people will be going with the time related columns. I will tell you that tomorrow. Date time, like month wise, day wise, year wise, month wise, 3 months wise. So that's all. Yeah, I'll be providing you access, guys. So I'm going to keep the notes access here. If anyone does not have access, you can check it from here. Data engineer, copy the link. I'm putting in the chat. Get it from here. The access to my notes.
Yeah. Okay.
Copy it from here. I'm going to close the session in next 5 minutes. Next 2 minutes. Yeah. Yeah. Copy it first. Okay, that's the notes access. You all have the access to the notes. You can check it. Okay. Yeah. Okay, guys. Thank you all. Yes.
Sir, I didn't get the notes link, sir.
What is mean by automatic? No, usually, yeah, we are not creating a table from the Terraform or this one, but we will be creating a table from the Cloud Composer, from the PySpark code, from the data flow, from the PySpark, whenever we see that as a pipelines, right? Okay. Yeah, we will be creating that, but not Terraform because we are not considering Terraform, but other tools, all the data engineering tools like Dataflow, Data Cloud Composer, and Cloud Functions, all of those things we will be able to create. Yes. Okay, guys. Thank you all. Hope you guys have access to the notes. Yeah. Thank you all. Have a great day.